All right, everyone, it's Mr. Ross here today. Today we're going to talk about periodic models. Take a moment and read this prompt here. Okay, you should pause it and read it because there's a lot there. Okay, so now that you're back, we have our water wheel here, and it's 10 meters across, and it's spinning at a constant rate. So in essence, what's happening is this wheel is going around like this. Okay, it's going around and around and around. All right, and so I do know that it's 10 meters across and it's 1 meter in the water. So if it's 1 meter in the water, down here to here is 1 meter. And if it's 10 meters in diameter, well, that means all the way up to here is 9 meters. From the water level to the top is 9, and so from the water level to the bottom is 1, which makes 10 in total. To the center of the wheel then, well, that's got to be 5, and this has got to be 4, and this has to be 5 to the center of the wheel. Okay, so there's a little bit of perspective of what's going on. Now, it says a certain one, Bob starts to watch the bucket go around. So at 4 seconds, the bucket is at the top of the wheel. So if I look at my wheel, so basically what's happening, the bucket's going around. So at this moment here, when the P is up top, in essence, Bob sees it, that's at 4 seconds when he started to see it. So it's going around 4 seconds, then it continues to go around, around, and then 30 seconds later, so in total 34 seconds, it is back at the top again. Okay, so it goes around, and 30 seconds later, it's at the top. So if I want to think about that, when is it going to be at the bottom? Here's 4 seconds, 30 seconds more is 34 seconds. So I know that halfway is the bottom. So 15 seconds later, after it reaches the top, it reaches the bottom. It keeps going around and around at a constant rate. So this constant rate idea here is important to know that it's going around and around. And the height can be modeled by this equation, but it has incomplete information. All right, so now that we understand this problem, which is always really important that you understand what is going on before you start just crunching through some algebra or numbers. So what is the maximum height that the bucket will reach? Well, if 0 is my water level, here is 0, here's going to be minus 1 in the water, so then my highest level it's going to be is 9 meters. How deep into the water will the bucket reach? Well, it's going to reach down here to -1 meters. So how high above the water is the center of the wheel? Well, it's 10 in total. Half fits 5 and 5, so I know that from here all the way up to the center of the wheel has to be 4 meters. So on a graph, it wants us to plot the point that shows the height of the water at 4 seconds. The reason for the 4 seconds, because at 4 seconds, it's at the top of the wheel. So when it's up here, it's 4 seconds. So it says graph that. So at 4 seconds, so here's 10, here's 4 seconds to 4, it's at a value of 9. So that's 8, so 9 is right here in the middle. Okay. Then it says plot the point for the next time the bucket is at its highest point. Well, I know here's at 4 seconds. It takes 30 seconds to reach the top again. So that's going to be 34 seconds. I am back up here. Okay, so now it says plot the point for when the bucket is at its lowest point in the water. Well, I know the lowest point is at -1, and it happens exactly halfway between those. So this is 30 seconds. Go from here to here is 30 seconds. So halfway is going to be 15 seconds. If I started at 4 and I go 15 seconds, 4 plus 15 is 19. And so I'm going to be here, but it's going to be 1 meter down low. And so that is going to be roughly right around here. This is the point 19, -1. This is the point 4, 9, and this is 34, 9. Now it says determine the amplitude. Well, if I consider what this is, what's happening here, it's going up, and then it's going down, and it's going up, and then it's going to go down. And so the amplitude is basically, if I go from the top to the bottom, that's 2 amplitudes. So 2 amplitudes, and I'll call amplitude A. So 2 amplitudes, 2 A's, is equal to 10. The distance from the bottom to the top is 10, and so the amplitude is 5. If I think about my water wheel, the amplitude is basically half the distance, or the amplitude is equal to the radius, or half the distance from the middle to the top, or the middle to the bottom. And it is synonymous with the radius is how we find the amplitude. And it's half of this curve here, half of this distance between here. That's amplitude. Okay, so that is going to be A. A is 5. Then it says determine the equation for the principal axis. Well, the principal axis is basically the halfway point between the maximum and the minimum. And if I want to find that halfway point, well, if I eyeball it, it's going to be roughly here. It looks like it's halfway here. I know I want 5 here and 5 here halfway. So if I'm at -1, up to 4 is 5, and 4 to 9 is also 5. So this line here, y equals 4, is the principal axis. And if I want to calculate, if I take the maximum y value, y, which is 9, and I add the minimum y value, so I add the minimum, and I divide it by 2, I will get 8 divided by 2 is 4, and this is going to be my principal axis, which is also called D. D is equal to 4. And if I look at my water wheel, it's the center of the wheel. Where's the middle of the wheel, and we know that that is at 4. And so each of these values corresponds to an aspect of the wheel. Continuing on here, so now we know A is 5 and D is 4. Sketch H of T below. Well, if I'm going to go here, 19, I go 30 more. I go 30 more here. That means I'm going to go 34 to 64 will be about here roughly. Then 64 to 94 will be roughly here. Halfway in the middle, 19 plus 30 is going to be 49, so roughly right around here. 49 plus 30 will be 17, so not right around here. And if I start to connect these points in a nice curve, it goes up and down, up and down. If I go to Desmos, you can see that here is my curve here with this particular scenario. And I can see clearly that these are my maximum and minimum points. Okay, so I'm going to sketch that value below. I sketched it above. Continuing on, so here's my equation. A is 5 and D is 4, which we figured out here. Here's my A value. The A is 5, so it goes into here. The D is 4, it goes into here. And I'm given this equation here. So I want to determine the height of the bucket when the time is 12 seconds. So if I think about this, if I look at my graph, at 12 seconds, here's 10, so it's roughly going to be about here. And so to find this, I'm looking for the height of the bucket when t is 12. So what I'm looking for is I'm going to find h at 12. And that will be 5 cosine 12 times 5 minus 48 plus 4. I can throw at my calculator. The easy thing I can do is if I go here, if I want to put it in my calculator to see what's going on, I already entered into here. And when I graph it, oh, that's a total mess. If that happens, let's think of a couple things. Let's think about our axes. And if I back up a second, let's think about our window. I want my window to go from negative, let's say 10, so negative 10 all the way to 90, or we'll say 95. And let's go by tens, so that each of these dark lines is 10. I'm going to go by tens. And then my y minimum, if I look at that, that's going to be like -3 to 14. So let's go from -3 to 14. And we'll also, to match it here, we'll go by 2's. And we'll go by 2's. And I'll graph it and we'll see what we get here. So when I pound that out, I will notice that this graph does not look like what we know it has to look like. The last thing I'm going to check is my mode. It's in radians. I am working in degrees because in 10th grade here we don't know radians yet. And now if I graph it, it clearly looks just like the graph we have here. And it also looks like this Desmos graph here. So if I want to find, so I did all that work because I had to find h of 12, and I can plug it in and do the calculation. If I do that here, I know this is y1. So if I trace my graph, and here's my cursor, if I just type in, I have the coordinates are shown. If I type in 12, it will just show me that h of 12 is equal to, what did it say? It says 3.48 meters. So what that means is at 12 seconds, so roughly here, it is at 3.47 meters. Okay, so in K part now, determine the third time where the bucket was at a height of 3 meters. And was the bucket going up or down? Well, in order to do 3 meters, I really want the h value to be 3. So I'm going to be doing the equation 3 is equal to 5 cosine 12t minus 48 plus 4. And if I consider a line here, okay, if I put my line, if I take my line and I place it here at 3, this is y equal to 3. What I'm looking for, it says determine the third time. Well, this is 0. Here's my first time, my second time, and my third time. This is what I'm doing. And if I can see, I'm at the top of the wheel and I'm going down to the bottom. So I am on the way down. This one is going down at this point. So in order to solve this equation, I need to find it. And if I estimate here, I know this is 50. That's 45. So I don't know, about 45 or so, between 40 and 45. I go to my calculator, and I have this equation in here. I'm going to make y equal to 3. And then when I graph this, I am going to go second, calculate. I'm going to do the intersection. My first curve is given. My second curve, it says y2. And now I want my guess. And so now I'm going to be careful. I want the one that it's close to here. So it's close to 40. I'll even go closer to 42. And I can see that it's 42.46. And so what time was it? Well, t is equal to 42.46. So it rounds off to 0.5 seconds. Okay, and that's what this value here means. Moving on now, it says interpret the value of h of 70 in this context. Well, what this means, if here's my time is 70, it's saying how high is the bucket when the time is 70 seconds. So h at 70, it means how high, it's asking how high is the bucket after 70 seconds. Okay, that's what that means. If I wanted to calculate, I can just put into my calculator, trace 70, and it tells me that I'm 5.5 meters above the water level. And then M part says, interpret the mean of h of t at 9. Well, h at t at 9 is asking, this is saying what time, because we're looking for time, what time is the height 9 meters. And if I look at that, well, here's a 9 meter, here's a 9 meter, here's a 9 meter, and so on. And so there's lots of different answers to this value, but that's what it means. And then finally, the last question says, how long does the bucket stay submerged in the water in each revolution of the wheel? Well, if I think about what this means, is that here is, if I take my y equals 3, I'm going to move it down to here. And let me clear all my marks off here. So I'm going to move my graph. So here is the water line. I want to know when and the bucket comes down. It's under the water, under the water, under the water. So I really want to find how long is it under the water from this point to this point. And so to do it, if I go to my calculator here, I'm going to delete this value. And if I graph it, I need to find these zeros here. I know each of these are 10, so if I go second, calculate the 0. My left bound, well, I'm going to use my, I know this is about 20, and then so this is going to be about 15, so I'm going to type in 10. I'm going to say 10 is my left bound. My right bound, I can see here from this graph that 20 is between the two, so I'm going to use 20. And my guess, I'm going to say 15. And so my 1, 0 is 15.9. And now I'm going to find the other one. So I'm going to do the same procedure, calculate the 0. I'm going to go from 20 now, 20, and I'll say, I don't know, 30 with my right bound. And I'm going to guess 21. And so now my other 0 is 22.07. So I want to find, so I know this happened, this is 15.92, and this one is 22.07. So if I want to find how long is the bucket below, I subtract those values. So if I take 22.0724 minus 15.9275, and I can see that it is underwater 6.14 seconds to 3 significant figures. That's how long the bucket stays below here. All right. So in doing these trig applications, you really have to understand what's going on, use the graph, use your calculator, use the context and the meaning to solve.